In this video, I'll be covering question 5, part C from the 2018 AP Calculus Free Response No Calculator Allowed portion of the exam. If you want to see the solutions for A, B, C, and D, I cover them all in their own individual videos, so please go check out those other videos. Alright, looking at C right now, C wants us to find the absolute minimum value of f on this given interval right here. So whenever you need to find the absolute max, absolute min of a problem, it is the same set of steps every single time. You should just have this process ingrained into you by this point. What you would do is you start off with whatever the function is you're given. So this would be e to the x times the cosine of x. Step one of the process is go find the derivative of that. So this would have been a product rule. And my product rule recipe goes fg prime plus gf prime. I label the first chunk the f piece, the second chunk the g piece, and then I just follow that rule to get my derivative. So f prime of x, first go grab f. F is e to the x. Multiply that by g prime. The derivative of cosine is negative sine. That's just one of those ones you have to have memorized. Plus, go grab the g piece, which is the cosine of x, and then multiply that by f prime. The derivative of e to the x is, again, something you just have to have memorized. The derivative of e to the x is e to the x. So from there, step two of our process is we need to go find critical values. So we're going to set this thing equal to 0, and then we are going to go ahead and try to find out when that occurs. So the first thing you want to do when you see a problem like this is if you can factor this at all, then you want to do that. And sometimes it's just your basic level of factoring, which is to pull out a common term. So I see that I've got an e to the x in both of these pieces, so I can pull an e to the x out of both of those, and that's going to leave me in the first chunk just negative sine of x, plus from the second chunk I will still just have that cosine of x right there. What that allows us to do when we factor is we can now break this up into two smaller bite-sized problems. So whenever e to the x equals 0, we will have a critical value, or whenever the sine of x plus cosine of x equals 0, we would have a critical value. Well, e to the x never equals 0. That's one of those ones they just want you to, you should know the e to the x graph looks like this. It's got a horizontal asymptote at 0, so it never reaches 0. So we can kind of ignore that piece for now. And that's, again, one of the advantages of doing our factoring. From there, to solve out this trig function, what you essentially want to do when you've got sine and cosine coming together and you're trying to figure out where does that equal 0, is you want to turn this, if you can, back into a tangent. And so tangent, remember, tangent of theta, the tangent of an angle is equal to sine theta over cosine theta. So what I'm going to do now is I'm going to try to get this to look like tangent. So I do that by adding the sine of x, add the sine of x. I get the cosine of x equals sine x. So I separate them out into two different sides there. And then I'm going to go ahead and divide by the cosine of x, divide by the cosine of x. And so I get out of here 1 equals sine x over cosine x. Or more importantly on this, I know that 1 has to equal the tangent of x. So from here, this is where we're just, again, this is all about knowing your unit circle information. And more importantly, knowing those special triangles. When I'm looking for when it's 1, that is always going to be coming from my 45, 45, 90 triangle. You should, it's one of those things I tell my students, write down your special triangles right at the beginning of the test, because you probably are going to need them, and if you've got them written down, then you can access them real fast when you're not in the middle of a problem. You can just pull up that piece of scratch paper and say, okay, which are my two special triangles? Because you should know your 45, 45, 90. You should also know your 30, 60, 90. So pi over 6, pi over 3, and so that would be 1, 2, square root of 3. And so again, My handwriting down there, that should be pi over 6. So that's your 30/60. So tangent, remember, thinking about your SOHCAHTOA, tangent is opposite over adjacent. And so what we're looking for is where would we have an opposite over adjacent that gives us 1? And if you had this triangle over here written down, you would be able to say, nope, that's not it. Here I can see that I've got an opposite and an adjacent that is going to give me 1, which is pi over 4. So right now I know that pi over 4 is going to be one of my critical values. Then you got to keep working your unit circle game here. So where else would I be looking for a tangent value to equal 1? Remember, all of these things have 2 quadrants that are going to give you what you need. So in this one, I always remember ASTC. This is where things are positive. Everything's positive in the first quadrant, just sine in the second quadrant, just tangent in the third, and just cosine in the fourth. And since I'm looking for where tangent is a positive 1, I know that that would happen in my first quadrant. That is pi over 4. That was the first one we got out, but it's also going to be positive down here in the third quadrant. So to get that, I would take pi, because that's 180, and I'm going to add to it pi over 4. So doing pi plus pi over 4, that's really going to be 4 pi over 4 plus pi over 4. That gets us 5 pi over 4. And so that's going to be our second angle here. 5 pi over 4 is going to be our other critical value. So we have 2 critical values coming out of there that required us to really know our unit circle like the back of our hand. So we've got those 2 critical values. So step 2 of the process is complete. And now we go to step 3 of the process. Step 3 of the process is you are going to plug in all your critical values and endpoints of your interval into the original function. So on this one, our endpoints of our interval are 0 and 2 pi, and we're plugging everybody back into the original function. And from that list of values, whichever one in this situation, because we're looking for the absolute min, whichever one is the smallest y value is going to win that absolute min award. So I would come back and I would do f of pi over 4. I'm going to do f of 5 pi over 4. And then I'm also going to do, because these are my critical values right here, that's the first piece, I'm also going to do f of 0, because that's my first endpoint, and I'm going to do f of 2 pi because that is my second endpoint. So these are my endpoints on this side. So we're plugging everybody back into that original equation. So this is e to the pi over 4 times the cosine of pi over 4. So here again is why you need to have these special triangles sitting in front of you. So e to the pi over 4, the cosine of pi over 4, cosine is adjacent over hypotenuse. So the adjacent side is 1, the hypotenuse is the root of 2, so we end up with e to the pi over 4 times 1 over root 2. So that's just going to be e to the pi over 4 over root 2. And then we go to the next one and we do 5 pi over 4. So this is e to the 5 pi over 4. And then this is the cosine of 5 pi over 4. Well, remember that cosine in this third quadrant where 5 pi over 4 is at is a negative value. And so we're going to have e to the 5 pi over 4, but this is going to be times negative 1 over root 2. So we're going to get e to the 5 pi over 4 negative in the front over root 2. So that's a negative number there. Coming over to the other side now, plugging in 0, we get e to the 0 times the cosine of 0. So e to the 0, anything to the 0 power is 1. The cosine of 0 is coming from our unit circle again, from this point here where 0 is at on the unit circle. That's the point 1, 0. Our cosine value is always the x value. The sine value is the y value. So the cosine of 0 is 1. So then out of there we get 1 times 1. and that's going to get us 1. And then we do e to the 2 pi, and then we get the cosine of 2 pi. Well, 2 pi is at the same position as 0, so the cosine of 2 pi is also 1, so we get 1 times e to the 2 pi, which gets us e to the 2 pi. Now from there, we need to pick the smallest y value. And luckily for us, there's only one y value that is negative. And so because we don't have our calculator, it's hard to calculate what e to the pi over 4 divided by the root 2 or e to the to 5 pi over 4. But as we look at this, we can say to ourselves, well, this value here, e to the pi over 4 root 2 is positive, 1 is positive, e to the 2 pi is positive, so all those are positive, meaning the only negative value has to be our absolute minimum value on this interval. So that's our final answer here. On this one, you would have ended up getting 1 point from doing step 2, getting the derivative set equal to 0. You would have gotten 1 point for identifying both of those critical values, and then you would have gotten 1 point for going through all of that work right there and getting out your final answer for your absolute minimum. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.